Question number 10. We have a coil of resistance 10 ohm and a given inductance 0.4 Henry and is connected to an AC source of 6.5 volt and frequency is 30 by pi hertz. We need to find the average power consumed in the circuit. Let's see what is happening in this problem. We have a resistor and an inductor like this, and we are connecting it to an AC source. R is given as 10 ohm and inductance is 0.4 ohm. And when we are given the voltage, whenever there is a voltage given 6.5 volt, that is the RMS value, not the max value, and its frequency is given as 30 by pi. LR circuit has a practical application. If you know about a tube light, this you can think of that there is a tube light has an inductor in series, and let us say this is our choke. Every choke has some resistance associated with it, and if this resistance is high, there will be power loss in this resistance. So anyway, we are required to find the power in this circuit. Power consumed in this circuit, P is given by V RMS multiplied by I RMS multiplied by cosine phi, where cosine phi is the power factor. And V RMS, we know we are given at 6.5, so we call it V RMS multiplied by I RMS is nothing but V RMS divided by the impedance of the circuit, we call it Z. What is the impedance of this circuit? Impedance of this circuit, R and L, is the combination of the impedance of R and L and is given by Z is equal to square root of R square plus XL square, where X is the reactance of the inductor and is given by omega L whole square. This is the formula you need to keep in mind to solve most of the AC condition, and similar formula for the capacitance. Cosine phi is given by R by Z. You will use the phasor method if you don't remember. I will have another video on derivation of this formula, so if you have any confusion, please go back and search for this chapter on the alternating current or inductor RL circuit power. You should be able to find the derivation and explanation of this. Now we can write it as V RMS square divided by square root of R square plus omega L whole square multiplied by R. Now let us take a look at this. If there were only resistor in this circuit, then the power consumption would have been P is equal to V RMS square divided by R. Because of this resistance R, let us say if you divide this whole circuit by, take this R down, then this will become 1 plus omega L divided by R. So this factor, the power, this bottom thing, whole thing has increased, and because of this power consumption will be reduced. So what is happening in this whole circuit? As a result of this inductor, our power consumption in the resistance as a whole has decreased, and therefore that is one way to divide this power. Even if we have, let us say if we have a tube light here, the tube light has a tube light resistor is such that if you give it more than a certain power, it will just blow up. It will destroy your tube light coil, tube light's resistive coil. So what we do is we insert. There was another option was we connect another resistor, a heating resistor in series with it, but that will make our power go waste in that heating resistor. So we connected a coil or a choke in that tube light that reduced the power consumption in this resistor. Now all we need to do is just put up the value. We are given V RMS is 6.5 into 6.5 divided by, multiplied by R is given 10 ohm, and R square is 100, plus omega is 2 pi into frequency, and frequency is given as, in this problem, as 30 by pi, right here, 30 by pi, 30 by pi whole square, and this bracket close. Pi cancels. We have 10 into 6.5 into 65 into 10 is 6.5 into 10 is 65 divided by 100, plus, okay, omega square into, you forgot this L. L is 0.4. So I will do some correction. Yeah. 2 pi into L whole square. This is L is 0.4. So this becomes pi cancel. 0.4 here into 0 and 0.4 goes. So become 2 into 3, 6. 6 into 4, 24. 24 square. 24 square is 576. And this becomes 625 into 65 divided by 676. 676. This will go by 13. 13 into 5, 52. And this will go by 13. This is 2.5 divided by 4. You can also write it as 5 by 8 watts. So it is consuming, now this whole circuit is consuming only 5 by 8 watts. If we had only this resistor R and there was no inductor, then the power consumption would have been P is equal to V square by R, or 6.5 into 6.5 divided by 10. And this will be roughly 6 into 6, 36, a little greater than 36 divided by 10, or it's greater than 3.6 watt. So with only resistor, the circuit would have consumed 3.6 watt, while with this inductor in place, this resistor, there's a power drop across this resistor is only 5 by 8 watt. One more thing, there is no power loss on this inductor in a complete cycle. All the power loss is only in this resistor.